Welcome for those of you on the Twitch. We are now broadcasting live again from the AWS Loft in San Francisco. For those of you here in the room, we're just coming back from lunch here for Serverless Day as part of the recap week here at the San Francisco Loft. For those of you who've been watching the Twitch channel, you just saw the previous session on Sumerian, and now we're back here in the Loft talking about serverless topics for the rest of the day. So we're into the second half of the day here. Got a bunch of fun stuff that we're going to talk about. Just recapping where we were in the first part of the day, we had an introduction to Lambda and serverless applications. We talked about Lambda and some of the product suite around that. We spent about an hour time talking about some of our tooling with AWS SAM and the SAM CLI. You saw how easy it was to take that CLI tool, basically start at zero, and build up to a running application and get things going. Now we're going to dive a little deeper into one of the biggest announcements that we had at reInvent. For any of you who are at reInvent or watched the live stream, Amazon CTO Werner Vogels announced this live on stage. From the product side, we were really excited. We've been working on this for a long time, and it's pretty cool stuff. So that's what we're going to spend the next hour on here. After this, then, we're going to talk a lot about API Gateway, dive really deep into that, and then we'll finish out the day here talking about AWS Step Functions. So let's get into that. For those of you who are just joining us live, who weren't here earlier, for those of you who are maybe here at the Loft who weren't here before lunch, again, my name is Chris Munns. I'm currently Principal and Lead Developer Advocate for Serverless at AWS, based out of our New York City office. I've been in AWS for a little over 6.5 years across a couple different roles. And before that, came from more traditional kind of startup, DevOps, operations background, managing infrastructure, both physically and in the cloud. So for today, this week at the Loft and on Twitch, we've been doing a recap of announcements from reInvent and kind of a catch-up on where we are in some of these product portfolio spaces. Serverless, again, is the topic here today. Now, in the center of the world for serverless for us here at AWS is AWS Lambda. And we talked really earlier about Lambda, again, being a compute service, various capabilities and attributes that it has, and the concept of a serverless application. And so again, a serverless application is you have some sort of event source, you have your function, which is code that you've written that responds to an event that you've configured. And then again, your code can do whatever it might need to do in terms of talking to databases, data stores, other APIs in the internet, services, et cetera. So we also talked a little bit about the anatomy of a Lambda function. And so we saw an example really early on here in the day where we had a really basic Lambda function, just a couple lines of code, where we have the handler, which is called here Lambda_handler. And this is kind of the interjection point that the Lambda compute service uses to start executing your code. That can get passed into what's called an event object. So depending on your event source, there could be data about, say, an API call, or data from an S3 bucket, or from a SQS queue, what have you. And that's going to be typically what you're going to interface with in terms of the customer action, as it were, that you have. And then we have the context object. And the context object represents information about the underlying configuration of the platform, both stuff you've controlled and then stuff that's just available to you. So now imagine this function. And again, this was a really basic function, right? All it did was spit out hello world, and that was kind of it. If we were to take this and expand upon it, and imagine, if you were, that we're going to build an API-based application. So the first thing we're typically going to do, and this is a general best practice for serverless functions at AWS, is we have our handler, but we're probably going to want to do something much more complicated with the business logic for our function. And so this is kind of pseudocode, so don't expect this to look exactly like any one specific language. But imagine that based on the event that we have, we're going to do one of two different things with the event structure, the data that's passed in. And so maybe what we want to do is break out two different sub-functions that represent some sort of business logic as part of that. And this is a pretty common model where you'll see the handler then pass things off to that sub-function that's a little bit more purposeful. Typically, though, this will be expanded upon, where what you're almost always going to have in most modern languages today are some sort of libraries that you want to import. And these could be third-party open source libraries, things from inside your organization, other stuff like that. There's also a concept inside of Lambda functions which is considered pre-handler code. Now, let me explain a little bit what happens with pre-handler code. And you see some of these lines up above here. Now, when we execute a Lambda function, or when a Lambda function invocation comes in, and we go and we take your code and we put that into the underlying compute resources that we have, and we do the first bootstrap of that environment. One thing that you might want to do is run some code before execution to do things like handle database connections, import libraries, talk to things like secrets managers or password stores. And then you could take those resources, those secrets, those imported libraries, and have those pre-existing so that in subsequent invocations, it can reuse those. So basically, this allows you to reuse active connections, active libraries, active bits of information inside of your function. Now, we will only call this code once during that initial bootstrap. And then again, as subsequent invocations come in, we'll look for then what's considered a pre-warmed environment and attempt to reuse these for you. And then over scale, you get more of these, and we fire more of them up, and they make those calls. So really common to have a Lambda function where you've got some amount of pre-handler code, so dependencies, configuration information, helpers. You may then have those helper functions defined. You then have your handler, and then you'll have like business logic functions in that same file. And now imagine, again, this could be a Node.js or Python or Java or whatever, general kind of structure that you're going to have. Now let's assume that I have an API-based service. So I have an API gateway, which again, we're going to go into a little more depth here later today. And then I've got a number of different API calls that I'm going to make off of my API. So I can call the orders API, the forums, the search call, et cetera, et cetera, et cetera. And then based on that call, I am probably going to talk to something, right? So my code is going to need to talk to databases or data stores. Maybe I'm getting configuration or secrets information from another service or what have you. So if we put all this together, what we could imagine is that I have a lot of these functions, and it is kind of a best practice to have a function per API call or per sort of different capability. And so for each of those bits of code, I'm going to have pre-handler information, imports, configuration information, helper functions, and probably some sort of business logic code or function. And so as we see here in this diagram, all of those kind of smaller blue boxes and the orange boxes could effectively be, to some degree, duplicated code. And so we could have a lot of duplication that exists. Right? We're just showing you a couple of these. If I had an API that had 60, 70, 80 calls in it, there could be a lot of duplication that might exist. And so the reality of it is we want something that looks more like this. We want our business logic and our handlers joined together. And then any of this helper stuff, any of this duplicated stuff, we would like to just be able to kind of glob that on with the rest of our function. And now, traditionally, you've been able to do this with things like traditional dependency management for a lot of languages, so native packages, things like pip packages or gems in Ruby, or NPM packages for Node.js, and there's all sorts of different ways of reusing code. But in the context of Lambda, some of this might be more specific, and it might be larger than just a single package. And so this was kind of a common pain point that we had seen with customers of Lambda. And so this led to us launching, again, just at the end of November, something called Lambda Layers. And so what Lambda Layers allow you to do is upload some blob of data. This could be those dependencies that we talked about. This could be that pre-handler code. This could be reused business logic. And treat it as a separate artifact from your actual application code. And then what we do at execution time is we actually merge all these things together for you and then execute your application. And so this can allow for a number of kind of really interesting benefits. One thing that we see today and that has happened in the industry is that obviously a lot of you probably are programming in languages that have open source packages that you want to include inside of your code base. There have been issues with things like security vulnerabilities in those, performance issues in those. You might work for an organization that wants you only to use open source software of certain licenses. You might also want to control people in your team from deploying all sorts of different versions of these and peg yourself on a certain version. And so layers can offer up a separation of responsibilities that can say basically, here's a layer that represents the approved versions of software X or Y. Or this is the locked version that we're going to support that security has looked through. Or hey, as a team, we're going to standardize on version blah, and here is the package that contains all of that and puts it together. This also can, again, be used for things like the pre-handler logic that we saw. So let's say that you have code that needs to get secrets out of AWS Secrets Manager. That's code that's pretty straightforward. And depending on what secrets you're getting out, it could be 20 or 30 lines of code. There's no reason to have that in every single Lambda function that you have. You could create a layer that has the code to talk to Secret Manager, the Secrets Manager SDK, or the AWS SDK, and maybe something like AWS X-Ray to do traces on those calls. Make that a layer, and then share that layer across your organization. And so there's a lot of things that you could do with this, and layers are meant to be shared, and they can be shared inside of an account, inside of an organization, or publicly out among whoever might want to consume one. So the way that layers work is just like with a Lambda function, you create a zip file and you upload it to the Lambda service. And then inside of your Lambda function, or in the configuration of it, you reference the layer as being part of it. Now, again, what we end up doing is we take the layer in your application code and put it into the same execution environment for you. Now, layers can be effectively stacked on top of each other. We'll talk a little more about that here in a moment. And so you can only, today we have a limit of 5 that you can have per function. They can be versioned, and they are immutable. So what this means is that when you upload a Lambda layer, and then you upload a new version of that, you can have both versions there, or you can tear down the old one, but you can never replace a version. So like once you have version 3, you can never replace version 3. You can only have version 4, 5, 6, and so on, and you can delete version 3 if you want to. And then you tell your Lambda function specifically what version to use. Now, ordering is important with these layers. So you will define them in a certain order in either your function configuration or if you're using SAM, which we'll show later here how you can do that. And then all of these get put into a specific directory in the runtime. So again, at the end of the day, Lambda is running inside of a Linux environment. You can actually go and poke around inside of your Lambda function and make shell calls and stuff like that to that underlying environment. But so what we do is we put all of this code into the /opt directory. Now, ordering matters because what we basically do is we squash all these down on top of each other. So if I had one layer and it had /foo.txt, and then I have layer 2 and it has bar.txt, in my Lambda function, I could see both foo and bar.txt inside of the same file system. But if I then had a third layer that also had a foo.txt file, that foo.txt would take place over the first one. So basically, it would end up overwriting what was there. Now, this could be important. You can use this to push out, say, specific updates to layers where you can't or you don't want to update an entire layer. You just basically push out an update to a single file or a single dependency. And so there's reasons why you might want to think about the benefits of this. But you also want to be cautious about how layers could potentially overwrite each other as part of this. And so, again, this provides some flexibility and allows you to have separation of responsibility inside of this. One thing that we see in the serverless space is we have a really awesome growing ecosystem of security vendors, profiling troubleshooting vendors, monitoring vendors. And so you can imagine a layer that is from one of our security partners. For example, a company called PureSec, which provides a tool that can do introspection on the events and what's going on inside of your function. You could have another layer from a company called IOPipe, which does profiling of the performance of your functions. And so each of those could be a layer, and then you could have layer for your own code, and you could put those all together, and it will all exist in the underlying application runtime. Now, one thing we didn't talk about earlier is for Lambda, per region, we have a storage limit for your functions and for your code. The default for that is 75 gigabytes. This is a soft limit. But one benefit of layers is that instead of every time you update your code, having all of those dependencies in your application, you can just have a layer that has it. And so that way you're not duplicating all of that code in the storage system as well. So a couple different benefits here. Now, depending on the language runtime that you have, inside of that /opt directory, what we've done is made it so that you can reference the code and the dependencies and stuff in there as if it was just in your code base. And so basically what this means is that when you go to do an import of a dependency, we've extended the path of the environment so that it knows to look in these directories for you. And I'll show how this is beneficial here in a moment. Bless you. And so you don't have to say import from a certain directory. You can just call import, and it will kind of just be solved for you. Now, I mentioned here that layers can be shared within an account, between accounts. So you can say, I only want to share this layer with this one other AWS account, or across the broader developer community. And so I'm going to share a link later to someone who has published a GitHub repo that's become kind of an unofficial list of shared layers and runtimes that people have open sourced. And so you can get some examples of what's out there. Now, when we launched layers, we also put out a layer for two really popular Python scientific libraries, NumPy and SciPy. They were two of the most heavily requested pieces of software in the Lambda execution environment. And so now you have this as a layer. And we're thinking about more layers that we can provide to you that will be for common utilities. A very common request is things like headless Chrome, other scientific libraries, and stuff like that we could put in there. So let's actually pause here. It's kind of an abstract thing to see from if you're new to Lambda. Let's actually dive into how this all works. So let's assume that I have a serverless application, and I'm actually just going to go real quick here, and kind of like most cooking shows, I already have kind of the semi-baked casserole in the top oven, and I'm going to put the raw stuff in the bottom oven here. But so this was actually from some code that I had from a webinar that I recorded recently. It's really basic. It's 4 files, and I'm just going to clone this. So I'm going to come back to my Cloud 9 environment, which I used in some previous demos here. And I'm going to do git clone and run this. OK. So this is a really basic serverless application. It has a app file. It has a SAM template, which is also pretty basic. And it has requirements.txt, which has a couple of third-party packages that I want to include. And now what this code does is it reaches out to a service called parameter store that we have here at AWS that, much like the name might sound, allows you to store parameters for things. So basically, key pair values in a hierarchical structure. There's a bunch of cool things that you can do with it. It's good for configuration information, for feature flags, for all sorts of environment information. And what's nice is that it is a centralized service. So all of the Lambda functions I have, and EC2 instances, and ECS containers, could all get that same information from there. So it can become kind of a centralized repo of information of any sort. So let me show you what I have here in Parameter Store. You find it under the Systems Manager console. So right now I have a couple different strings, or a couple different parameters that are saved. I have demo, I have one called Hello Loft, one called I am, and one called webinar. Let me go to Hello Loft, and let me change this, and say hello everyone at the SF Loft, and then save this. Okay, so 4 of these here today. So let me go back to my code here, and let's say that I'm ready to test out this application. So again, here in the console, I can just go and open another terminal window. I can go into the directory for this. I can call sam build to pull in all of my dependencies. And so I showed you before I had a requirements.txt that just had three packages that I cared about in it. But what's interesting is that those 3 actually pulled in about a total of 30 different dependencies. And so this is a very common thing that people are finding in modern languages today. You have dependencies that have dependencies that have dependencies in an open source world. Now, there's a lot of risk that can be introduced to this. Just about 2 months or so ago, there was a open source Node.js package that had malicious code inserted to it that was stealing people's Bitcoin wallet information from their local system. And it was a package that was not a very popular one by its own name and identifier, but it was included in a lot of very, very popular Node.js packages. Which is why I always do development now in a dedicated host. I don't want anyone to steal any of my information like that. But again, if you thought about it, so I had 3 things that I required, but again, it expanded out to all of this other stuff. So it's a common thing you want to be care of, and again, it's why layers can be beneficial to you. So I have my built directory. I did sam build. It pulled all those in. I can go into the AWS SAM directory, into build. I have my template, and I have my code directory here. I can go ahead and test this API. It's fired up. Let me just check something again here. It lives just in the raw path for this. So let me do a curl without hello at the end. Cool. So if you can make this out here, it's just kind of a blob, a JSON blob. But I basically have a structure called messages, and then I have 4 key value pairs: hello loft, demo, webinar, and IM, and it corresponds to the data here in this service. Super straightforward. Let's actually take this code and let's deploy this. So I'm going to call my SAM package command, which is just going to zip up this code and shove it up into S3 and create an updated SAM template that references that. And then I'm going to deploy this as a stack. Now, I happen to have a stack already existing for this. I'm just going to update it. The stack is called get messages, and so it is just going to go and update this serverless application. Okay, nothing here is new or specific to layers. Just taking a serverless application, pushing it up into prod, and updating it. Again, with all of these packages and stuff in there. Just a moment or two for it to finish updating. Cool, so successfully updated my stack. Let me go back to the Lambda console and go to applications. I see get messages here was just updated. I can go into it. I can expand out my API, go to API endpoint. Again, I see the same messages that I just saw locally in my IDE. I can also go and take a look at the Lambda function for this. So I can go into the Lambda console for the function. And so I see that I have my function defined here. I've got some permissions on the right side for Xstring, CloudWatch logs, and the parameter store manager. I've got my API gateway. But when I click on the Lambda function in the console here, I could scroll down, and what I see here is that it says, this package is too large for the inline code editor. But again, we pulled in like 60 dependencies from Python, and so that's not too surprising. You can only handle more basic stuff. So this is here. Now, imagine that for this application, these dependencies are super, super standard. Boto is the AWS SDK for Python. X-Ray is a tool that we have for tracing and troubleshooting calls. In this case, setup tools is another Python library that helps with management of all this stuff. There's a good chance as a Python developer for Lambda functions that I'm going to include these in almost all of the functions I'm ever going to create. Anything that's going to deal with an AWS service is going to have these three libraries. So I could potentially be having not just these three libraries, but the 60 dependencies that they brought in every single Lambda function that I ever create that's Python-based. If I were to do this and upload those and have this happen to be part of my step, it would be really wasteful. It'd be a lot of data. I'd have to manage the versions and think about that. And so this could be something problematic. So what can we do better? Well, this is where Layers comes in. So I'm going to come back here. I'm going to go ahead and delete this built version of my code. I'm also going to come in here, and I'm going to delete the requirements.txt. And I'm going to say that there's going to be no requirements off of this function, just app code and a SAM template. Again, going back to kind of cooking show style here, I'm going to come back to my repositories. And I already have a repository that represents a layer that's going to have all of those same dependencies in it. So let me just clone this real quick. Okay. Great. So I have another directory here. In this directory, a git ignore, a readme, a requirements.txt, and a template.yaml. Now, I had mentioned before in SAM that we have a new resource, this resource here called layer version. And so what layer version does is basically allow me to create a new layer. And so it references here the layer name, a description, where the code is going to be in like my directory structure here, compatible runtimes. And so depending on what language I use, it could be something shareable, license information, and then a retention policy, which has to do with if I delete my layer, do I want to still keep record of it internally? So this is here. So let me go back to my command line and go to this directory. I'm going to run, actually, in the README here, I've provided instructions. So I'm just going to run pip install. So pip is the package manager for Python. So I do pip install. It's now going to pull in all those 60 or so various dependencies that I have. And I can see that now inside of the Python subfolder. Now, why the Python subfolder? Well, I had before in a slide, depending on the language that you have, the directory structure that you need so that my code can just find this without me having to import it based on the path of like the operating system. So for Python, that means putting it in a Python subfolder. So all these are here, exact same stuff that was in my application code. Great. This is technically a serverless application, right? It has a SAM template. So I am going to do a SAM package again. We're just going to zip this up and update a template file. And then I am actually going to deploy this as a layer. There we go. So SAM deploy, and I have a stack name called Lambda Layer Bodo X-Ray. So it's just taking all these dependencies and it's uploading it just as a layer. Takes a moment or two. I need some like Jeopardy theme music that I can just like play for this. Cool. All right, so it's done. It has created / updated the layer Lambda Layer Bodo X-Ray. I can come back now in here to the Lambda console, and I can go to layers, and as you might expect, I see my layer defined here. So I can find out all sorts of information about it. It was just created 25 seconds ago. The license that I've referenced. You can see here I actually have a couple of versions of this. So I'm now up to version 5. All of my previous versions are all here, and I can come up here to, or actually from here I can actually select a different version. So let me go to version 1. And you know what, version 1 is old, and so I'm going to delete this. And so it basically will say that no one could launch a new function referencing this. It doesn't break existing functions, but version 1 goes away. So I got version 5, and now what I want to do is I want to have my running Lambda function be able to reference this layer. And so I copy this thing here called a version ARN, and an ARN is basically a resource identifier in AWS's terminology. I'm going to go back to my IDE. I'm going to go back to the template file for my application. And now what I want to do is add to it a capability for my layer. So in SAM, I do layers. I am going to substitute the value for it. I could type in like an actual name, but I have to use the ARN for this. And I'm going to save this. I'm going to go back into a terminal window. I am going to package this. Pretty quick. And then I am going to deploy this. So this is going to update the Lambda function that I have configured in that whole application. And in this case, now I'm uploading it without any of those dependencies in my application artifact. And I am now referencing my created layer as a layer that should be used. Again, we've got some hold music. Just a moment. Cool. So that's done. So the real testing of the demo gods here. Let's go and refresh this. And it worked, which is just pulled up the same information. Let's actually go ahead and just create another parameter. So put in the namespace messages / call it post layer, test after layer. Cool. Go back up and refresh this. Cool. So somewhere in here is post layer. If I come back to the Lambda console and I go and find that serverless application and I find get messages, I will, oops, let's refresh that. Find get messages, and again here I see the information about my Lambda function. Let me actually go again into the function console for this. And I'll see something a little different. So I'll see here now that it references that there is a layer attached to this function. and I could scroll down and find the version, the merge order, et cetera, information about it. If I click back on the Lambda function and I scroll down, now I can actually see the code in the code editor, because my application artifact now is under the size restriction for the console, and so I can see it. And I see that I just have my app file, I have my template file, it references my layer, and so that's all good. Now, all I would need to do going forward for any of the other functions that I had, any of the other serverless applications that I had, is just reference that layer. And so, again, you can imagine where, again, this represents the layer for me talking to any AWS service plus having X-ray tracing. You can imagine, again, the layers that you have for some of these third-party tools for monitoring or logging or security. You can imagine layers that maybe represent certain code that your organization needs, or things like SSL certificates or configuration files or all sorts of things that you want to standardize out across the applications. So that's AWS Layers, or I'm sorry, that's Lambda Layers. And again, really brief, quick example there. So took an application, had a lot of dependencies, uploaded it, said, you know what, I don't want all these dependencies dependent on that app, pulled it out, created a layer, configured the function, used the layer, pushed it back up. I didn't touch my app code. Nothing in my application code changed. I didn't have to change my import structure or the calls for that. Nothing about my actual application changed to use layers. So really powerful and easy to get started with. We'll transition to the next part of this session here. So again, Lambda's been around now for just about 4 years. And one of the tenets that we hold really close to ourselves on the Lambda team is that we want to make it really easy for developers to get started. I was actually just in Seattle for the last 2 days, meeting with various Lambda team members of ours, talking about new features and things that we're looking to build this year. And we will get legit heated with each other about making sure that we don't impact the ease of working with Lambda. We want to keep that bar really, really low. And so one thing that we've done to help keep it really low when we first launched the product was having managed languages for you. So providing languages that we handle the patching and the updating and give you new versions of them and expand those over time. And so to date, basically what we have here is a number of different languages. I've actually removed the ones that are now deprecated because we do follow the life cycle of the ecosystem for these languages. And so you'll see here that we've got different versions of Node.js and Python and .core and all sorts of, .NET Core and other things out here. And the reality is that the languages that you see here represent a really large majority of what most of you are probably writing applications in today. It's a huge chunk of the industry that uses just those languages and has been pretty happy. But what we know is that that's not everyone. And so there is a really big long tail of languages out there. Stack Overflow does a yearly developer study. In that developer study, they highlight the most popular languages that developers are using. It's maybe a little hard to see here. Some of the very top ones are things like JavaScript, HTML, CSS, and SQL aren't really related to what we're doing on a backend side. But you see in here Java, you see PowerShell, you see Python, you see C#, you see things like PHP. But it's a long list. There's a lot of things that we don't have managed in the Lambda environment. Similarly, GitHub does their State of the Octoverse, which tracks top repositories by language, as well as the growth of languages inside of the GitHub Octoverse, as they call it. And they show things like Rust and Groovy and Kotlin growing really rapidly. These are really exciting languages. People are finding them really useful for certain use cases. And so we know that you care about these languages, and we want to help you use Lambda to have event-driven workloads with them. And so this led to us launching custom runtimes for Lambda. As you can imagine, this basically allows you to bring any of those languages that we didn't support previously to Lambda. So you want Rust, you could bring Rust. You want Groovy, you can bring Groovy. You want Kotlin, you can bring Kotlin. You want to bring COBOL? You could bring COBOL. I don't know why, but you could. So there's all sorts of things that you can do with this. And so this is powered by something called the Runtime API, which we're going to go into a little bit here. And basically what it does is it provides a standardized interface for running any language you want. Now, we built this for two reasons. One was to enable y'all to be able to run whatever code you want inside of Lambda. The second is we actually needed to, on our side of things, provide a better internal standard for this. The different languages we originally had different ways of working in our platform. And so we actually now use the Runtime API to power new language support. And so we announced Ruby as a managed language, but behind the scenes, it uses the Runtime API. And this will allow us to kind of have mutually beneficial new capabilities to the platform that benefit the managed languages and the languages that you run over time. Runtimes can be distributed as a layer. So we saw before here, create a layer, have code that you want reused. And so you could have a layer that represents a runtime that you use across your organization, and there you go. So when you're creating a function with the Runtime API, instead of choosing one of the managed languages, you choose provided as a language. That's what it looks like. And then inside of either your layer or your application artifact has to be an executable file called Bootstrap. As the name might imply, this is what we use to bootstrap or configure and set up the environment so that it can execute whatever code you want it to execute. And so basically, you have just an executable called Bootstrap. We'll show how this can be in a number of different ways, and then it will execute the code on your behalf. Now, the Bootstrap does a couple of different things. It basically acts as a bridge between this thing called the Runtime API and your code. So imagine it as kind of the gateway or the shim that sits between those two things. And so it has to be able to react and talk to the Runtime API behind the scenes, which handles things like actually passing events into your code and explaining to the Bootstrap how your code is configured, so like where the handler might be. And there's other information that it has to handle as part of that. And so it basically has to listen to a local interface in the execution environment to do that. And then it will interface with a local API, the Runtime API, in order to get information. And so the API for this is actually really, really basic. It's just a couple of calls that are available. It's not this like massive, expansive thing. So we see here that when you go through the initial bootstrap, if things don't work out, you have to be able to post an error. Otherwise, you would get, see here, the invocation next. So give me the next event. And then this will pull down the request information that you want to pass into the event. You would then post either a response or an error message, and that's it. So you bootstrap up the executable, you get an event, you execute that with the handler code, and then you post back a response or a failure. And you can see here how that gets pulled out of an HTTP endpoint down below. Inside of it, when you're actually doing the processing of the event, you have to, again, get the event. You have to propagate something called a tracing ID. You have to create the context object. So that's that object we talked about that gets passed into a function that has certain capabilities and information about the environment that your code might interface with. You have to invoke the function handler. So you have to actually call the execution of that, and then handle response or errors, and then any cleanup that might need to happen. Another part of this is that we pass in environment variables. So these environment variables tell the Bootstrap information about, again, the execution environment, the handler, the task group, so where the code lives, whether it's in a layer or someplace else. So with this, you can execute pretty much anything. We have people running essentially shell scripts that execute other binaries. There were some folks, so there is a open source functions as a service platform that runs in Kubernetes called Knative. People have gotten Knative to run in Lambda via this, so you can have portability for your functions in and out of different clouds if you wanted to do something like that. But there's a lot of different things for this. Really key though, most of you in this room will never touch this. You will never touch the Runtime API, you will use the managed languages. We will continue to grow and update the managed languages over time. That's where we want to see people be. We really don't think that you should have to use the Runtime API unless you're going to use one of these unique languages. So useful to know about, but you're probably not going to end up using this too much yourself. Now, when we launched this, we at AWS open sourced a couple of runtimes, as well as worked with a number of partners on a bunch of other runtimes. And so we announced a C++ and Rust runtime that are built by us. And then we have partners, so Alert Logic announced one in Erlang and Elixir. Those were two languages that they use really heavily internally. And so they had been looking for support in Lambda for those for a really long time. So they kind of built it for themselves and the wider community. A company called Blue Edge actually did launch a COBOL custom runtime. So they work with a lot of companies that have old COBOL code, and you can take that COBOL code and run it in Lambda now. A company called NodeSource has what they consider to be kind of a high-performance, high-grade quality Node.js runtime that's available now. And then the folks at Stackery who have a tool for managing serverless applications, they like PHP, and so you can, via their runtime, run PHP in the cloud. You'll see at the bottom here, there's a URL. You could also Google just GitHub awesome layers. And the person here has a collection of links to all of the custom layers and custom runtimes that have been shared out there among the community. If you create one that you want to share, you just go and issue a pull request against this and say, here's my layer. People can go and find it. And so this thing continues to grow like every day. A lot of cool stuff being shared by companies. We have a lot of AWS partners, again, like in the tooling space, which are launching layers. So Datadog announced a layer for their monitoring tech to be put into Lambda. And so again, there's a lot of things that if you have a company that provides software that other people might consume, creating and publishing a Lambda layer could be a way for you to distribute your product, just as an example. So let's take a little bit of a look at this. I started doing PHP back in like the year 2000. And so I was really excited when I saw that Stackery announced this. And let's actually go ahead and take a little look at what a custom layer looks like. Okay. So we'll start in the directory that they have in GitHub, the repository, I should say. So they have a really basic repository. They have a whole bunch of shell scripts that they use for management of the layer, things that publish the layer, pull it down, update it, things like that. They've got a make file for compilation, a license, a README, and then they have a bootstrap. Really, the thing of value here is the bootstrap. So if we come in and take a look at this bootstrap, the first thing that you notice is that this is a PHP script itself. So this is basically going to say, assume that our layer contains the PHP binaries, and I'll show you how they do that here in a second. We're going to execute PHP to run PHP. Pretty straightforward. They have down in here then a function called start web server. And basically what this does is it runs the process that is going to talk to the Runtime API. It's going to init itself. It's going to look for the next event, and then it handles response or errors back from that. And it pulls in a bunch of the environments variables, so it gets the handler, it gets a couple other things inside of here, and then it executes the actual code that needs to run. So a bunch of flags on this, but at the end of it where it says handler file name, that's basically it saying, okay, we're going to execute this code inside of here. They also have some failure handlers, and that's actually a huge chunk of the rest of this, where they basically provide the support for handling the request and for failures and stuff like that. But this is 238 lines of code, which really is not a lot of code for what this does. It's really straightforward. It's a very, very kind of vanilla bunch of system calls and curls to API interfaces, getting environment variables and handling responses. There's a significant amount of white space and stuff. So it's really probably 150-ish or so lines of actual true code, in this case PHP. If we go back to the main directory here, and we go to the build.shell. So what they do, and when you're building runtimes, we encourage you to use an AMI or a Docker container that matches the Lambda execution environment. And we publish what those are in our documentation. And so you would want to run basically an install of PHP. And then you create some directories. And you basically package this up as a layer. And then it's deployed. So they have here in this directory all the instructions you need for getting started with their PHP layer. And really, it's pretty much, if we scroll down through here, that you create a SAM template that references their public layer. Now you could fork this repo and create your own custom layer for PHP, and you can own it and track it and all of that. But they are providing this as a managed layer, and we can actually see here that they are up to version 7 of their layer. And then you just write some PHP, and you publish it. So if I go here to the Lambda console, and I go to functions, And I'm going to go down to my PHP test. We can see here, if we look at this, I have some really basic code. I just say, I can't believe this is PHP. And then I actually call some PHP. And so PHP info is a native call inside of PHP that prints out some interesting stuff here, which I'll show you in a sec. I then have an API gateway in front of it. And so let's go ahead and pull this up. Cool. How many of you have ever developed in PHP before? A lot of you. Yeah. So you've probably seen this before, right? So this is PHP info running in a Lambda function, responding back through an API gateway, which is generating this HTML. And PHP info provides lots of information about the underlying operating system and runtime. And again, this is the stuff running in Lambda. So the Lambda OS version that we use and stuff is shown here. I can come down here and see Lambda-specific environment variables and versions and keys and other stuff that are here. Again, nothing necessarily too exciting about this beyond the fact that we have PHP running in a Lambda environment. And again, all I had to do for this was I have a SAM template that references a layer that Stackery has shared. And again, this could be one that I've created too. And then there's a SAM template for this that manages all of this for me. And I can go and look at that SAM template. So again, in a perfect world, you're going to be consuming a layer that's shared by a community or by a company or by a group. Or you're taking one of these repositories, forking it, creating the layer yourself, or the runtime yourself as a layer and referencing it, and then again, run any code that you could think of. If you want to figure out how to build your own, again, there are examples from all these companies that have published runtimes of these bootstrap files. It's really, really easy to do it. It's effectively just a glorified shell script that makes some API calls for you. Cool. So, cool. So we talked about two new kind of concepts here in serverless applications with Lambda. Both of them are here to really kind of help simplify and make the development experience for you better. The first one here with layers, we saw how you can simplify reuse of code objects, of dependencies, of packages, of anything you want to throw into a zip file that needs to be shared across functions. And again, in the example of I have 3 requirements that expands out to 60, you don't want to have to schlep that stuff around every time that you upload and push up an artifact. We then saw with the custom runtime environment how we get that long tail of languages that you might want to use. And so at this point now, you can build event-driven applications that execute only for when they need to, tied into an event source in any language that you could think of. Small asterisks, there are some things that don't run in Linux today. But there's a lot of cool things out there, a lot of things that are possible. And again, these are 2 new capabilities. They are just a couple weeks old. So get your hands on them, give us feedback on them. We'd love to know more about how you feel about them or what we can do to make them better. As I've mentioned earlier, but for those of you who are maybe just joining or haven't been here yet today, you can go to awsamazon.com/serverless to find out more about all of this stuff. We've got links to Serverless app repo, which is something we talked about earlier, documentation, developer tools, resources like getting started guides, webinars, and stuff like that, as well as AWS partners. Again, my name is Chris Munns. I am Principal Developer Advocate for Serverless at AWS. You can find me at munns@amazon.com or at Chris Munns on Twitter. And we're going to take a quick break here and get started on the next session at the top of the hour, where we're going to be talking a bit in depth here about API Gateway and building and managing APIs. And so that's up next. But thank you all for joining. Thank you for coming to this session. For those of you on Twitch here, stick around again. We're going to get started on the next topic in just a couple minutes.